Hey guys, and welcome back. So this is Unit 1, Day 4 notes on rotations, Day 1. Our objective will be that students will be able to rotate a figure. So all a rotation is a turn about a specified point by a certain degree. And we'll always in this class go around the origin, and our degrees will be 90, 180, or 270 in different directions. And it is an isometry. So remember that means that it is the new figure will be congruent to the original figure. So your image is congruent to your pre-image. One thing to note, counterclockwise is positive, so it would be labeled in a positive degree. So when you get into like Math 3 and you start talking about trigonometry, you'll start talking about angles of angles. And if it's positive, it's always counterclockwise. Think about your quadrant system in a graph. When you have your 4 quadrants, this is your first quadrant, and then you go counterclockwise to label the rest. So counterclockwise goes in the opposite direction of a clock. Clockwise would be negative, and it goes in the direction of a clock. So you just want to kind of remember that. So if we're looking at this picture down here, we have this triangle ABC. We're rotating it 90 degrees clockwise. That means that we are going 90 degrees to the right direction. And what makes it 90 degrees is the angle that's created from the center of rotation between the image and the pre-image. So if you were to draw a line and create the angle between C prime and C, it will create a right angle. And it would do that for all of your points. So A to D and then D to A prime. They form right angles. So if we had a protractor, we could measure that. And then again, also from B to B prime. So they create these right angles, and that's how you find your center of rotation and how you find where your image should be. So we talked about in class today some rotation rules, and you've kind of found them on Desmos. So I'm just going to kind of reiterate them here. So remembering 90 degrees counterclockwise would go this way 90 degrees, and it switches the order and changes the sign of the original Y. And I'll talk in just a second about a way to help you remember that. 180 degrees, there should be a little degrees there. Counterclockwise, doesn't change your order, but does change both of your signs. And 270 degrees counterclockwise, again, is going this way. And it's going to change your order, but it's actually going to change the sign of the original X. It's important to note that 90 degrees counterclockwise and 270 degrees clockwise end up at the same location. And that's because 90 plus 270 is 360, which would be a full rotation. And thus 360 minus 90 is 270. So they would meet at the same spot. So you really only need to remember one set of rules, and then you can just apply the rules to the clockwise by finding the matching or the inverse one. And we're going to look at that in an example in just a second. So we have this table, and we're going to fill in our new points based off of our rotations. So I've already graphed this triangle ABC onto this graph over here, and we're going to rotate it for each of them. Now, what's important to remember is you're rotating about the origin. And so your coordinate plane is already cut into fourths. So thinking about a circle, the number of degrees in a circle is 360 degrees. So when you think about 190-degree rotation, that's one quadrant rotation. So remembering this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. When you move 90 degrees in either direction, you only move into one other quadrant, so the next quadrant over in the direction you're rotating. So when we're rotating 90 degrees counterclockwise, we're going backwards from the way a clock goes. So since I'm starting in quadrant 1, my entire triangle will end up in quadrant 2 because that is 190-degree rotation. The other thing to remember is that every 90-degree rotation, the order of your ordered pair switches. So when I go 90 degrees counterclockwise, my order of my numbers will switch. So it's 2, 3, so it's going to become 3, 2. So when I put my point A prime over here, there's A prime, the order switched. And if I were to connect to the origin and A, you can see that that creates what looks like a 90-degree angle. Now, the signs can be easily figured out because in the second quadrant, the first number is always negative and the second number is always positive. So my 3 needs to be negative to make the point make sense. If the 2 were negative, then A would be down here and then it would not make sense anymore. Doing the same thing with B, it's at 6, 5, so it's going to go down to negative 5, 6. So there's B prime. Again, I changed the order and the sign of the first number to make it match the quadrant. And then C is going to go to negative 1, 6. Again, switching the order and negating the first one to make it match the quadrant. So to help you with the signs, to reiterate, all I do is think about how many quadrants I'm going to go and what the signs of my answer should be for a point in that quadrant. So remembering that in quadrant 1, I'm at plus plus. Quadrant 2, I'm at negative plus. Quadrant 3 is a negative negative. And quadrant 4 is a positive negative. So you can just match your signs to the quadrant. When you want to do a 180-degree rotation, it doesn't matter which direction you go because both clockwise and counterclockwise are the same. So it's a 2-quadrant rotation. So I start in quadrant 1, and then I'm going to go through 2 and end up in 3. So it always ends up in the diagonal quadrant. Since the order changes every 90 degrees, the order flipped to get to the second quadrant, and then we'll go back to normal for the third quadrant. But all of my answers in the third quadrant are negative, so the signs of both of them will change. So A is at 3, 2, 3. So now over in quadrant 3, it will be at negative 2, negative 3. So that will be A double prime. For point B, it was at 6, 5. So in a 180-degree rotation, it will be at negative 6, negative 5. And then in C, it was at 6, 1. So now it's going to be at negative 6, negative 1. And then we connect to see our triangle. The orientation of your triangle switches for each rotation. So finally, looking at 270 degrees counterclockwise. Again, we're going to be going backwards of a clock. So when we're starting in the first quadrant, 270 counterclockwise is 3 90-degree rotations because 270 divided by 3 is 90. So it goes from quadrant 2 to quadrant 3 to quadrant 4. So your order of your points will switch to quadrant 2, then switch back to quadrant 3, and then switch again for quadrant 4. So once again, the order of our ordered pairs will switch. So we're at 2, 3, so we're going to end up at 3, and then we have to go down 2, which makes us at 3, negative 2. Point B is at 6, 5, so it goes 5, 6, 6, 5, 5, 6 again. Again, we're at in the fourth quadrant, so our X value will be positive and our Y value will be negative. 6, 6. And then lastly, C is at 6, 1. So it'll switch to 1, 6, switch back to 6, 1, and then switch again to 1, 6. Since we're in the fourth quadrant, the 6 needs to be negative. You can always check yourself by then saying, okay, well, if I did one more rotation, that'd be another 90 degrees. I would flip it back, so it'd go back to being 2, 3, which would end me back at my regular original pre-image A point. I find it easier to kind of picture where my graphs should go in order to find my signs instead of trying to remember the rules. Just remember, counterclockwise goes backwards for a clock, and each quadrant is 190-degree rotation. Gets a little tricky when it's a figure within 2 quadrants, but just whatever quadrant your point starts in, just think about what quadrant it should end up in. It's also important to note that 90 degrees counterclockwise is the same as 270 degrees clockwise. The rule stays the same. And so if you think about A starting here, 90 degrees going this way, we're going to flip the order. So we're at 2, 3, so it would be 3, 2, and we're in the fourth quadrant. So that makes it a negative 2. So you see that a 90-degree rotation clockwise is the same location as a 270-degree counterclockwise rotation. Again, because 90 plus 270 is equal to 360. It's very similar to percentages. So if you think about if you're buying an item that's 20% off, you're paying 80% of the price because those two things add to the total 100% of the price. 90 and 270 add to the total 360-degree rotation, which is why they are the pairs that go together. And then 270 degrees counterclockwise is 90 degrees clockwise. So if you wanted to rotate it just 90 degrees, you could just go the opposite direction. Let's do a couple of examples and then we will do more in class on Tuesday. So rotation of 180 degrees about the origin. My triangle here is starting in the third quadrant. So my final answer should be in the first quadrant because it's 180 degrees. That's two 90-degree rotations. So that covers 2 quadrants. Q is on the line. So this one's to get a 180-degree rotation, I need to go from one axis to the next axis to the next axis. And so Q prime will end up straight up there. The line between your 2 points should be a straight line through the origin. H is down here. So since it's in the third quadrant, again, it's going to end up in the first quadrant. We're at the point -3, -5. So when I move one quadrant, it goes to -5 or 5, 3. And then I go up one more, and it goes to 3, 5 again. Since I am in the first quadrant, they will both be positive. J is at the point -5, -3. So going 90 makes it 3, 5, and then another 90 goes back to 5, 3. And since we're in the first quadrant, they would both be positive. So what you want to imagine is that if you had this triangle traced on a piece of tracing paper and you put your pencil excuse me, on the origin and rotated it 180 degrees, where would your triangle end up? And again, you can see that it does make a straight line through the origin to get from the image to the pre-image. Looking at number 2, we want to rotate 90 degrees counterclockwise. So that is going backwards from your clock. So if I am starting here at L, I am at the point 5, 0. 90 degrees counterclockwise is going to go this way, 1 quadrant, so it's going to be at 0, 5. Looking at S, S is at the point 2, 2, so it's going to go to negative 2, 2. And B is at the point 4, 5, so it's going to go to negative 5, 4. Let's do one more, number 3, and then we will be done. So looking at number 3, we have that we are going to rotate 90 degrees clockwise. That means we're going this way. So if F is starting in quadrant 2, it's going to end up in quadrant 1. So it's at the point negative 1, 3. 90 degrees makes it switch, so it's going to be 3, 1. B is in the second quadrant as well at the point negative 5, 1. So when it goes to the first quadrant, it'll switch order to be 1, 5. M is in the quadrant 3, so it's going to end up in quadrant 2. And it is at the point negative 4, negative 2. So it will be at negative 2, positive 4. Again, switch the order and then make it match the points, match the signs. And then H is at negative 1, negative 2. So it is in the third quadrant. We'll end up in the second quadrant at negative 2, positive 1. So there you have your rotated figure. That's all we have for today. I hope that you enjoy your asynchronous day and get lots of work made up, and I will see you on Friday.